Hello everybody, so today is the 19th of May and we're having a group meeting about the project, the nutrient recovery project. The things to discuss today will be about a presentation that we're going to do today, also about our lab work in the last week and the planned activities for lab for the last 2 weeks. Now we'll talk about anaerobic digestion. It's also known as fermentation, and it consists of the degradation of sewage sludge by a population of microorganisms and at ideal conditions. It requires strictly anaerobic conditions, meaning that no oxygen, nitrogen or any other oxidant can be present on the system. And compared to aerobic digestion, it is cheaper and has a lower energy footprint. It can be utilized as for production of heat and steam, also as a vehicle fuel and energy generation, and last production of chemicals.
So I'd like to talk about the air stripping.
Yes.
Could you tell us how it goes?
Yeah. Last week we did it with the new sludge, but we have also before treat and before hydrolysis and after hydrolysis. We were using the before hydrolysis sludge and it was very solid. We had to dilute several times, and we after discussed with Wilfred that it will probably be affecting a lot of the pH, because we have to raise the pH to reach the desired conditions. So he suggested us to use the after hydrolysis sludge. Okay. So for our lab work last week, first maybe beginning with air stripping.
Okay, air stripping.
Everyone, so we're going to present our preliminary results so far for lab work. The theme of content of this presentation is the development of the project, the result itself, and the planned activities for the next. And so for our first few weeks on the lab, we started working with primary sludge that we collected from the water board Domo at Tilburg wastewater treatment plant. We started working with our setup for air stripping and the fermentation. Air stripping worked at first, but no biogas was produced with that sludge. We changed to the new sludge, after hydrolysis sludge. Air stripping was no problem because it was liquid sludge. But we didn't see biogas production with that type of sludge also. We worked with the same setup of the previous one, but still we didn't see any change. And we discussed with our tutor that we also will use both non-hydrolyzed and hydrolyzed sludge for our result, because that will be more complete for the client. And the solution for that is for the non-hydrolyzed one, we're going to measure the amount of TSS and make sure that we use the same amount of the hydrolyzed one to be comparable. The summary of this meeting, first about our presentation, we already did it. For the lab work, air stripping already finished with hydrolyzed sludge. It was successful. Fermentation, the problem was with the water bath. With the hydrolyzed sludge, we didn't get it for more than 2 days. So we used the same setup, same conditions as the other one. Still no biogas was produced. Parameters, we already measured all the ammonia concentrations of our samples of the hydrolyzed sludge, and still we have to measure NKO, COD, ammonia for the non-hydrolyzed sludge, and we have to strip and ferment the non-hydrolyzed. Yes, okay. Thank you.
Thank you.